Hello everyone, Ariam here, and welcome back to another episode of Draw and Discuss. Today we're going to talk about some really big bugs. Now, bugs are a topic that a lot of people seem to dislike, and I get it. There is probably some sort of evolutionary ick factor in our genetics that say, no thank you, anytime we see a spider, a bug, or any sort of other creepy crawly. But I find many different types of insects and arthropods and other icky sticky things pretty interesting, especially when they used to be gigantic. Around 300 million years ago, about 70 million years before the first dinosaurs started to evolve, the Earth looked very different. This period of time is known as the Carboniferous period, and due to the high number of lowland swamps and lowland forests, the oxygen levels in the atmosphere rose to about 30%, which is 50% higher than current day levels of oxygen. A boost of oxygen like this sounds great, but honestly, most organisms are so delicately balanced in how much oxygen they're able to exist in that modern day humans would really not benefit at all from that much oxygen. It would probably kill us. After I recorded that sound bit, I realized that I actually wanted to do a little bit more research on this, since I thought, don't certain athletes use additional oxygen for training and things like that? So here's what I found. So modern day oxygen levels are about 21%, and in the Carboniferous period it was about 30%. Humans are really well adapted towards our current 21%, and guidelines for oxygen masks say not to go over 28% in order to keep the patient healthy. So, since supplemental oxygen aids for athletes or for patients with low blood oxygen levels generally max out around 28%, the 30% or higher of the Carboniferous period would likely have given us hyperoxia, or oxygen poisoning. The amount of oxygen versus carbon dioxide being traded out in your body would upset the chemical balance in your lungs and in your blood, and you would eventually die. So yes, humans would not like living in the Carboniferous period. It would kill us, which is interesting. But moving back onto topic, you know what this high oxygen level didn't kill? The bugs. During the Carboniferous period, there were some truly large insects and arthropods. So why is this, and why did they, thankfully, shrink back down to today's sizes? So bugs don't breathe in the way that we breathe. We have lungs, we inhale oxygen, we trade out oxygen for carbon dioxide in our lungs, and we exhale the waste carbon dioxide. Now, things vary a little bit between insects and arthropods and true bugs, but the general rule is that for quote-unquote bugs, they actually take in oxygen and do gas exchange through small holes in their bodies called spiracles. So, if a bug has a larger body surface area, it can have more spiracles, and this requires less overall energy used at each spiracle, making gas transference a little bit more efficient. So it's believed that the higher levels of oxygen in the air may have allowed bugs to get really big because it made their gas exchange processes way more energy efficient. And the reason they got smaller today is because once that oxygen level started to drop, they could no longer sustain the surface area and oxygen requirements held at that level. Now, this is a really long-lasting theory, and a couple of changes have been added to it in recent years to kind of adjust what we think about this more oxygen equals bigger bugs kind of theory. A few researchers have proposed that instead of oxygen allowing bugs to get bigger, bugs had to get bigger in order to survive more oxygen. It sounds like just a tiny, subtle wording difference in the theory, but it's more of a, ooh, more oxygen is good, let's get big to capitalize on it, versus, ooh, this oxygen level is toxic, let me get big to reduce its effects on my body. It's believed that this would have especially applied to insects who have a grubby larval form or a larval form that exists in water, like dragonflies or damselflies. This is because those soft bodies of grubs or water-faring insect larvae actually don't really have a ton of control over their own gas exchange, so oxygen would have been entering their body kind of without their consent, and so they would have had to grow really big really quickly just to avoid oxygen poisoning. Whatever the reason, in the Carboniferous period, bugs were ginormous, so let's talk about a few of the most famous examples. First up, what I'm drawing here for you today is the Meganeura, a species of giant ancient dragonfly. This was essentially the same as dragonflies are today. They are relatively unchanged. They would have been an apex predator of the skies around swampy areas in their environment, except the difference is that the Meganeura had a wingspan of about 2.5 feet. This means that if they existed today, instead of dragonflies zipping around a pond and eating flies and mosquitoes and other insects, well, this guy would probably be eating songbirds and squirrels. And considering I've seen videos of praying mantises eating hummingbirds much bigger than they are, it's scary, but if you want to look it up, I encourage you to do so. Honestly, I wouldn't put it past a modern-day Meganeura from going after chihuahuas and other similarly large, but still tiny, mammals. I really have no way to scale the Meganeura that I'm drawing for you, since if I draw it with a prey item from its time, the prey would have been big as well, so the scale wouldn't change. So let's just pretend it's clear that this bug's about the size of a seagull. Next up is the very famous Arthropleura, which is a genus of giant millipede. Arthropleura was the big bug that I was planning to draw for this episode since it's my favorite and I love him very much, and I even had a really cool modern day millipede picked out to base it on, the pink dragon millipede. But it turns out when you have an animal that is flat and boxy and you try to draw it in a geometric style, it just looks like a rectangle. So while Arthropleura may not be the star of this video, it is the star of my heart because I would keep one of these as a pet in a heartbeat. I actually already keep several wild-caught millipedes and hope to buy some really interesting species in the future, and they feed on plant matter and rotting leaves and things like that. They are not predatory like their much scarier cousins, the centipedes, so a giant millipede sounds like just a backyard dog that you can pat all the time. I love it. And you could definitely pat this guy pretty hard without worrying about squishing him because it's believed the Arthropleura could have been over 8 feet long. It's believed that these big boys would have just been kind of ambling around their environment, eating rotten wood, staying low to the ground, and just being little tanks that wander around kind of like Roombas, cleaning up the ecosystem. Interestingly, most modern-day millipede species, including that pink dragon millipede that I showed earlier, are able to secrete cyanide compounds when they're startled. So they're definitely a wash your hands after handling kind of pet. I wonder if Arthropleura was able to do the same. There's obviously no real way to tell this from the rock impressions of an exoskeleton that is how we know Arthropleura existed. And from what I was able to research, it seems that because these cyanide secretions are an anti-predator defense, and because Arthropleura was so big and probably didn't really have any predators as an adult, maybe it couldn't secrete cyanide. But then again, they didn't hatch out at 8-foot-long armored tanks, so maybe they could because they were babies at one point. Maybe only the babies had cyanide secreting abilities. I guess we'll never know. Now, there were definitely some big bugs during this era that do give me the shivers, even as a bug lover. The Pulmonoscorpus kirktonensis was one of the largest scorpions to ever live, with at least one individual exceeding 2 feet, being 28 inches from pinchers to stinger. Now, I wasn't able to find out any information on the size of the pinchers of this scorpion, which is generally a good way to tell if the scorpion is highly venomous or not. In the scorpion world, you can really only put points towards either pinchers or stingers. So if a scorpion has big pincers to crush its prey, it probably doesn't have very strong venom. However, if a scorpion has teeny tiny fragile little pincers that are only used to hold prey, you better watch out, those are the dangerous ones. So while this 2-foot scorpion was definitely terrifying and you wouldn't want to take a pinch or a sting from it at all, I wasn't able to find out any information on how venomous it was, so maybe it would just have been like a big bee sting. I would not be the first one in line to test that theory out though. Next up is the Megarachne, or the Megaarachne, which if you split that word apart, it's exactly what it means, big spider. If the estimates about this spider are correct, it would have been around 2 feet long on the body, not including those legs, which would make it the biggest spider to have ever lived. I am actually a proud tarantula owner. This is my female Chilean rosehair tarantula, Philomena berta, and as a proud tarantula owner, I can tell you with certainty that this ancient spider is the scariest shape I have ever seen. Something about this thing really just fits into the uncanny valley for me. It makes me so uncomfortable, and I am so glad that there aren't any living spiders that look like this. The closest thing that I can think of is a camel spider, which is still terrifying, so something about this shape is just not friendly. That's it for today, so make sure to thank your lucky stars that bugs decided to evolve downward in size again, and maybe don't be so freaked out every time you see a house spider now, right? And remember to smile.